All right, so in this example, we're going to be continuing on from example number 5, which was we were just graphing the greatest integer of x. Now we're going to be graphing the greatest integer of a third x minus 1. So let's think about what this is going to look like then. If we're taking out a third of it, if you kind of think about that, then that means it's going to extend our line. If you look at back at what we did on the last example right here, it's gonna extend this out by a third, because if you think about it, if we take x, right, and then now what we want to do is we want to multiply it by a third, which means that if you take its greatest integer every time, whether it be the first third, the second third, or the third third, it's always gonna, that means that its greatest integer, if you round down, is always going to be now length of 3. So if you're thinking right now, dude, I have no idea what the heck you're talking about, watch how this works right here. All right, so we'll just start off with 0 here. We'll go ahead and plot some points, and we'll see if we can make some sense of this. We'll start with 0 right now. So, oops, x and y. So if I start out with 0, right, if I plug in 0 right here, that's 0 minus 1, negative 1. So the greatest integer of negative 1 is just negative 1. Cool. If we plug in negative 1, actually let's do positive 1 actually. So that's 1/3 times 1 is 1/3. So 1/3 minus 1 is a negative 2/3. Right, so negative 2/3, if you think about it on a number line right here, right, and if this is negative 1, so that's 1/3, 2/3. So if this is negative 2/3, then what's the greatest integer if you round down? Well, it would be negative 1, so that's why this is still negative 1 right here, right? You got to round down right here to negative 1. If I plug in 2, 2/3 minus 1 is negative 1/3 right here. Oh, but what's the greatest integer rounding down? Oh, we have to round to negative 1, so it's going to be negative 1 again. All right. And then if we plug in, if we plug in 3, so now we have 3 minus 1, and then we get 2 right here then. All right, let's see here. Yeah. So, oh, I'm sorry, 3 times a third is 1, 1 minus 1 is 0 right here. All right, I guess that makes a lot more sense there. We're going to get 0. 0. So let's see if this makes sense here. So at 0, we have negative 1. At 1, we have negative 1. At 2, we have negative 1. And then at 3, we have 0. 3, we go to 0 right here. So once again, we have this little thing here where it goes solid, solid, solid. But then right when you get to the x value of 3, it's an open circle. And then it jumps up here. And then like, did you notice right here how we went over 1, 2, 3? And that's what I was trying to say right here, is that because it's now cutting it into thirds, that tells me that our line just got extended by 3 units. And so that's how I know that now this is going to be 1, 2, 3, and then open circle. And then 1, 2, 3, the open circle, and so forth. And then, you know, of course, we can go and do this down here. 1, 2, 3. And close that right there. So yeah, so I mean, go ahead and, you know, like if this was 1/4, then that means that this would extend this by a 4. And then this negative 1, whatever number this is, that's going to move our line up and down. It's going to be our vertical shift. It's the same kind of thing like if it's a linear function or something like that. It's going to have that same kind of effect right there.